finally, as the last video of this subprograms sequence series, we are going to learn about local and global variables. So there's not actually really any new content here. We're going to look at functions, we're going to look at return values, but we're just kind of understanding a bit more why. I actually pulled this from my A-level content, but it can crop up on a GCSE paper, but you're definitely looking at some of those higher end skills. So we've seen this before, but the scope of a variable is just a part of a program that a variable is defined in and recognized in by the program. So for example, if you've got this function that returns the area and perimeter of a rectangle, area is only defined in this bit here. So if we were to print area, notice that's outside the scope of this function. It's not indented, so the function's ended. Area and perimeter have been deleted from memory, so area is not defined. Okay, now they have been returned, but we've not actually done anything with that return. We've not called the function, we've not done anything with that return value, so area is not defined. If you wanted this to work properly, you would need to return area like we did. I guess you could return perimeter as well. And then when you call the function rectangle, we set a equal to, or you could call it area, equal to the name of the function, and whatever's returned will be stored in this variable a. Okay, so in this case, it would return 15, store 15 in a, and now when we print a, it works just fine. Okay, so area has the same scope, but because we return it and save it in that variable, we can use it outside of our function. So global variables have a scope of the entire program. Okay, they're defined outside of functions or procedures, they're defined in your main code, and you can use them wherever you want to in that program. Local variables have a scope of the function or procedure that they are defined in. So they only exist inside that function, and if you try to reference them outside the function, you will not be able to. Okay, so let's look at this example. Now, we've been given quite a complicated function here, and that's absolutely fine, because the goal right now is not to understand how this function works, but just to understand which variables are local and which are global. But just for a quick rundown, our function countx's passes in word as a parameter, turns that word to uppercase, and this for loop is it's a shortcut way of iterating through a list where it creates a variable letter and it will look at every letter in that word. If the letter is equal to x, we're going to add 1 to our count. So it's just counting the number of x's in a word using this fancier for loop. Now, outside of our function, notice it's unindented. We have the user enter a word. We call this function count x's on that word. We've called it string. Save it in the variable x's, and then we print out x's. So first variable up is word. Now word is passed in as a parameter. It is only defined in this function count x's, so it is a local variable. Okay, our next variable is count. Count, again, it's defined in that function, so if we were to print count outside, it would not work, so it's also a local variable. So even though it's returned, that's fine, it's still local. The next one is letter. Again, defined inside of our function, local variable. Okay. String is notice it's defined outside. This is in our main program, so it's going to be a global variable. And then x's is our last variable, and this is created when we call the function count x's, but it's still defined in our main program, so it is a global variable. Okay. So now let's have a think about what will actually be outputted. So we've got this function called myFunction. Okay. Inside of my function, a is 3, and we return a. So if I call my function, I then set a to 4. Think about what will be printed. You might want to pause it. Okay, and here 4 is going to be printed because we've set a to 4. A will become 3, but as soon as that function ends, a is going to be deleted from memory. Okay, let's do another example. So this time, same thing, except we're flipping the order of these. So a is 4. We call my function, which sets a to 3, and it returns a, and then we print a. So you might want to pause the video. All right, and the answer is still 4, because even though we call my function, this variable a is a local variable. It's actually a different variable in memory. So even though it has the same name, it's a different variable. It does not overwrite this a is 4, so when we print a, it's still going to print 4. Okay, as soon as that function ends, that a is deleted out of memory. Okay. And this one, we've got my function, a is 3, same function, b is set to 5. When we call my function, right, we set this variable a to 3. We return a, but we're not storing any variable here. So when I print a, again, you can pause it, it's going to return error, because as soon as this function ends, A is deleted out of memory. So when it goes to find this variable A, it doesn't exist. So it's going to print an error. So let's look at some examples live just so I can kind of prove to you that it works as we think it does. So we've got this function. This one actually takes in a parameter and it's going to add 5 onto that parameter before returning it. All right, so absolutely fine function. The function itself has no problems. So let's start with this code. So if we start with A is 6, we call my function with A. So this A here is, so we're calling my function with 6. It's going to say A is now equal to 11. It returns A. When we print A here, you can pause it, you can guess what it's going to print, but it's going to print 6. Because even though it's changed this value A here, it's just changed what we pass in as a parameter, it's not permanently changing this one in memory. So this A and this A are different. If I were to run this, this is basically the same code as this, where these are separate variables. Okay, so you could call this B and it's a different variable than that A. Okay, but if we go back to the A's, let's say I actually wanted it to work. Notice because we are returning A, if I overwrite my global version of A with my function, now it'll return 11 because, well, it was always returning it, but now it'll print 11 because I'm overriding that global variable, and then I can output it here.